Hello everyone, in this lecture we will study about CM sensing with resistive sensing. Now Vout CM, that is Vout common mode, is given as Vout 1 plus Vout 2 by 2, where Vout 1 and Vout 2 are the single-ended output. Now we employ a resistor divider as shown in this figure. Vout CM is equals to R1 Vout 2 plus R2 Vout 1 upon R1 plus R2, as can see written over here. That is the resistor divider level. Okay, the difficulty however is that R1 and R plus and R2 must be matched greater than the output impedance of the op-amp so as to avoid lowering the open loop gain. To eliminate the resistive loading, we can interpose source follower between each output and its corresponding resistors. As shown in this figure, this technique produces a common mode level that is in fact lower than the output common mode level by VGS 7, 8. Okay, but this shift can be taken into account in the comparison operation. Now R1 and R2 or I1 and I2 must be large enough to ensure that M7 or M8 is not starved. Okay, when a large differential swing appears at the output. Now as shown in this figure, if Vout2 is quite higher than Vout1, I1 must sync both Ix and ID7. Okay, this Ix is given as Vout2 minus Vout1 upon R1 plus R2. And consequently, if R1 plus R2 or I1, this I1 is not sufficient large, then ID7 drops to 0 and Vout CM is no longer representing true output common mode level. So the drawback of this particular circuit is that it limits the differential output swing even if R12 and I12 are large enough. The swing at each output is reduced by approximately VTH, a significant value in low voltage gain. Okay, and another type of this common mode sensing is depicted in this figure. Okay, here an identical transistor M7 and M8 operate in the deep triode region, which introduce a total resistance between P and ground which equals to R on 7 in parallel with R on 8. Now, keeping the values as 1 upon mu n cox W by L V out 1 minus VTH in parallel with 1 upon mu n cox W by L V out 2 minus VTH, where this W by L represents the aspect ratio of M7 and M8. Okay, for the solving we can write as 1 upon mu n cox W by L V out 1 plus V out 2 minus 2 VTH. And the use of this M7 and M8 basically limits the output voltage swing because V out minimum is given as VTH 78, which is relatively to the 2 overdrive voltage. But the difficulty arises from the assumption that above both M7 and M8 operates in the deep triode region. And if this Vout1 drops from the equilibrium CM level to one threshold voltage above ground and Vout2 also rises by the same amount, then M7 will enter the saturation region, thus exhibiting a variation in its on resistor that is not counterbalanced by that of M8. So in this particular common mode feedback using a MOSFET, we have used two transistor M7 and M8 in the deep triode region, okay, which will introduce a resistance between P and ground, okay, and the use of this M7 and M8 basically limits the output voltage swing. Okay, so this is all about this. In the next lecture, we will study about sensing and controlling output common mode level. Thank you.